Okay, now we'll see how to solve alpha beta pruning problem. So there is one first problem which is having A, B, C, and also children's for them. So first you can see that the root node is having a minimum, and then next to that root we are having maximum level. So if you want to solve alpha beta pruning problem, we must be knowing some rules and conditions for that. So now how we are going to calculate a max value and how we are going to calculate a min value. Here max value is nothing but alpha and min value is nothing but beta. Now initially alpha, that is max, is having minus infinity, b is having min value is plus infinity. So now if a particular node is like a maximum, what how the value is actually going to take means, now max of minus infinity comma any value, for suppose like 1. So max of minus infinity comma 1, so minimum value is 1, so that current node will be assigned 1 as that particular time. Next, beta, that is minimum. So this is also having a minimum of plus infinity comma any value. So if you place any integer like 1 or 2, 3, so that will be the value for the beta. Okay. And this most important condition, that is when we have to prune or when we have to skip that particular path of traversing, means we have to satisfy this condition, that is alpha greater than or equals to beta. In some they will be given like a beta less than or equals to alpha. So any of the condition is true, and then we are going to prune that particular path. Okay, now we'll see our problem. Now there are nodes like A, B, C, D, E, F, G, where A is the parent and B is the child, C is also child to A, and D, E are the terminal nodes or children for B, and F and G are terminals or children of C. Right now we don't have a values for A and B since it follows the DFS, so we are going to get the left side of that our uh, tree. Okay, so see here from min max we are going to get that for terminal node D, which is value is 2. Now this value need to be copied to the maximum node. So how we are going to copy this maximum node is, what is the formula or what is the uh, uh, procedure to calculate the max value, means nothing but minus infinity comma value. So what is the value that we are going to supposed to copy to this particular node, means that is 2. So value is 2. Now alpha max, that is alpha equals to max of minus infinity comma 2. So what is the maximum value of minus infinity comma 2, means 2 will be the maximum. So at this level, this particular, that is B node will be assigned as a 2, right? So B node will be assigned as 2. Now so far completed. Now see here again, if we are not going to directly to the min. Why? Because we are still having one more node, that is E here. So we have to calculate that also. That is maximum of minus infinity comma 2 comma 4. So what is the maximum of that one, means 4 obviously. So that 4 value will be copied to the B node, right? Now every time we get alpha or beta value, we have to compare or we have to check the condition. Okay, what is the condition? Alpha greater than or equals to beta. Now I'm having here alpha, but I'm not having beta. So there is no possibility of checking that condition. So directly I can move this value directly to the root node, that is A4. Now after that, so A is having one more right child, that is C. So how we can calculate the values for it? See here. Similarly, directly it will goes to the F terminal. Why? Because no values are there. Here there are no values, so directly it goes to uh, F node. Now how it is going to calculate means, since it is a maximum, so max of uh, so here I forgot to say one thing, that how this A node will be getting means min value is 4, right? How it is getting means directly we'll get like minimum of plus infinity comma minimum of plus infinity comma 4. What is the value? 4 is the minimum. So we'll be getting like 4. Now coming back to this right child of A, C, how we got 6 here? See here. Now it directly goes to the terminal node F, right? This is 6. Now, what is this level? This level is maximum level. What is the formula for calculating the value of maximum is alpha equals to max of uh, minus infinity comma value, right? So here it is C value, how we are max of minus infinity comma 6. So what is the maximum of minus infinity comma 6? 6 is the maximum. So 6 is assigned, right? Okay. Now you have to remember one thing, that we got here alpha value and there is also alpha beta value. So whenever we are having a parent and child alpha and beta, then we have to compare, or we have to check the condition alpha greater than or equals to beta. Now what is alpha? Means maximum 6. What is beta? Minimum, that is 4. So 6 greater than or equals to 4. Yes, it is true. Condition satisfies. Now, whenever this condition satisfied, no matter whatever the next path or next s- uh, children is present for that particular node, we are going to prune that, or we are going to neglect, or we are going to skip that particular path. So that's how here we are going to skip the G terminal without traversing, without moving. Directly we are going to assign C value as 6. If we come down, we see here finally. So this path or this terminal node we are not traversing. Why? Because here at C level, alpha is 6. Here beta is 4. Uh, Alpha 6 means 6, beta is 4. Alpha greater than or equals to beta condition is satisfying. So that's why we are going to skip or prune or not moving to this particular one. This is how we are going to calculate this alpha beta pruning.